Today's topic is going to be about difference arrays. Now, just to quickly go over what a difference array is, the concept is actually very simple. Say we're given this initial array, which is drawn in blue. The difference array is simply just the differences between each consecutive element. So as you can see, the difference between A and B is the first element, the difference between C and B is the second element, and so on. How exactly is this useful in Codeforces? Let's take a look at this problem. Extreme subtraction. The premise of this problem is quite simple, actually. You have an array of positive integers to start, and in any one operation, you can pick a number k and choose to decrease the first k or the last k elements. And all we want to know is whether it's possible to make this entire array equal to 0 or not using one or more of these operations. Let's take a look at these two operations over here, where we pick an element k and increase the first k or the last k elements. Now, it might be a little hard to wrap our head around these specific operations. So let's go ahead and try to see if there's a transformation we can perform on the array that simplifies these operations. The first question I would ask myself is, how do these operations affect the difference array? Let's go ahead and take a look at that. Okay, so this is what our initial array looks like. Let's go ahead and let's choose k equals 3 for an operation, and we want to decrease the first k elements. So then the new array would become something like this. Initially, the difference array would look something like this. D minus C and E minus D. And after this operation is performed on on the first k elements, where k is equal to 3, our new difference array will become B minus A, C minus V, D minus C plus 1, and E minus D. So right away, we can notice that the difference array doesn't actually change except for the single element over here. And it turns out that this actually holds true for any operation you perform on the prefix. Okay, that makes this operation much simpler to deal with. Instead of it changing k elements, it only changes one element. So this gives us a hint that this operation is simplified. Now let's take a look at the second type of operation, where we choose some value of k and decrease the last k elements by 1. So from the original array, it would turn from this to this. Pretty simple. Let's figure out what the difference array looks like now. So B minus A, C minus B minus 1, D minus C, and E minus D. Only one value changes here as well. We should definitely consider this as a simplification that we can perform. If we take the difference array and just perform all these operations on the original input, we can just look at how the difference array is affected, and the operations will only affect one number at a time rather than up to n numbers at a time, because k can go up to n. So here's a quick summary of what the operations do to the difference array. One thing that we do have to keep in mind, however, is that the difference array does not store information about the value of the first element, which in this problem is important because the value of the first element can potentially give us a cue as to how many operations we are able to do. So for example, if we have an array of like 0, 3, 1, then this isn't actually possible because there's no way that we can create operations from a prefix because we don't want to decrease the first element because it's already 0. However, if every element were to be increased by 5, for example, 5, 8, 6, while the difference array would be exactly the same, the first element is different, and that gives us more options to do operations on the prefix. With that being said, let's take a look as to what kind of operations we can do. So our new goal is to make all elements in the difference array 0 without making the first element negative. In our difference array, if we were to have a positive number, then we can just use operation of type 2 to decrease that value. And that's pretty straightforward. And there's no repercussions in doing that because that just decreases a value in the difference array. And because it's an element, an operation on the suffix, the first element of our array should be unaffected. However, the case is a little bit different for type 1 operations, where we can increase an element in the difference array. If we need to increase an element in a difference array, that means that the first element of the initial array has to be currently positive. And the reason why is any operation we do on the prefix, no matter how big or small this prefix is guaranteed to decrease the first element of the array by 1. So with this conclusion, we can assume that for any negative element in a difference array, we have to move a 1 from the first element of the initial array to that negative element in the difference array. And if this is not possible to do at any time, then the answer is no. This whole problem can be implemented like this. All we need to check to determine the answer for this problem is to find the sum of all the negative elements in this difference array, which I have described as array, and psums is just the input array. And when we find the sum of all the negative differences in this array, we just check to see if the sum of all these elements, absolute value, is less than or equal to the first element of the array. If it is, then the answer is yes. Otherwise, the answer is no. I hope this video was helpful. Let me know if you guys want to see more content like this, where I just talk about a specific tip or strategy that I use to solve problems efficiently.